Normally, planets orbit around stars. But did you know there are planets that wander the universe without a star? These starless planets are known as rogue planets, and we have evidence of their existence. In 2016, the Kepler telescope provided significant evidence for the existence of rogue planets. Over a 2-month period, Kepler observed millions of stars in the central part of the Milky Way, capturing images every 30 seconds. Scientists analyzed these images to identify the gravitational microlensing effect. Gravitational microlensing occurs when the gravitational field of a massive object, such as a star or planet, acts as a lens and magnifies the light from the more distant background object, like another star or galaxy. According to Einstein's theory of general relativity, mass curves the space-time, causing light to bend. This bending effect is similar to how a lens works in optics, hence the term is called as gravitational lensing. In microlensing, the lensing object is usually a single star or a planetary system. Unlike strong lensing, which can produce multiple images or arcs of the background object, microlensing typically results in a temporary increase in the brightness of the background object. The degree of magnification depends on the alignment of the source, lens, and observer, with maximum magnification occurs when they are nearly perfectly aligned. Rogue planets can act as a gravitational lens when it passes in front of a more distant star. As the rogue planet moves between the observer, usually on Earth, and the background star, its gravitational field bends and magnifies the light from the background star. This temporary increase in brightness is observed as a characteristic light curve. For rogue planets, microlensing events typically have a very short duration compared to those caused by stars, lasting from a few hours to several days. By analyzing the light curve, astronomers can determine the properties of the lensing object. The duration and shape of the light curve, combined with gravitational lensing models, allow researchers to estimate the mass of the lensing object. If the mass estimate falls within the planetary range and no host star is detected, the lensing object is identified as a rogue planet. During the observation period, scientists identified about 27 objects that were not visible under normal conditions for durations ranging from 1 to 10 days. They determined that 4 of these objects were approximately the size of Earth and were only observable due to the microlensing effect. If these objects were orbiting a star, the observable duration due to the microlensing would be longer. Therefore, the shorter microlensing scenarios suggest that these objects are more likely to be rogue planets. How a rogue planet is formed? One widely accepted theory is that rogue planets are ejected from their original star systems through planetary ejection by stellar encounters. During a close encounter, the gravitational pull from a passing star can disturb the orbits of planets in the original star system, making their orbits more eccentric or altering their orbital planes. This disturbance can destabilize the planetary system, causing some planets to gain enough kinetic energy to be ejected from their original star system. With future observations, we will obtain more information about these mysterious rogue planets. Stay tuned for more updates in astrophysics by subscribing to our channel.